this gives me an immense pleasure to talk here and address the August gathering. So with as we see most of the pioneers, even the experts in structural engineering, and from yesterday's morning to till today, we have learned a lot of things with respect to the structural design, fabrication, retrofitting, health monitoring, and so on. So I'm standing here being a structural engineer, but I wear the other hat to present here, like well before the couple of presentation. One of the sponsor is presented on digital technology. So here I'm trying to connect the structural engineer and digital technology with the help of, we have a lot of advancement in our digitalization. So where you would be even little be worrisome for us, like the same worrisome we had it when AutoCAD was introduced, right? And now that worrisome has been continued since then. Like we had AutoCAD, and then later we have many of the 3D modeling tools or softwares. Now recently, like we slowly started adapting the BIM. Even we have seen in a couple of presentations yesterday. And now I'm going to talk about artificial intelligence, right? So that is the talk of the day. So most of the talk will be covering on artificial intelligence, but I'm just trying to touch upon how we can connect it, because you have seen from the earthquake resistant structures, and you have seen from the morning session, so where there are kind of thermal power plant towers were retrofitted, a lot of data were collected, and how these data are being effective in civil engineering. So why do we just care about, by just introducing some of the courses, like being an academic side, I can understand that a lot of institutions are going with introducing the courses or even degrees on artificial intelligence, right? So now, as a structural engineer or as an engineer, you would be thinking about, okay, if I'm talking about the AI, so what kind of a job I'll be, or like this AI will replace, right? So the kind of a job what AI would be replacing, so as I said, the same concern we had it when there were like the hand drafting. So I think nowadays, even none of our colleges we would be seeing of any of the hand drafting devices, right? So it's already, we cannot see that it's in absolute. Like then we also thought like, okay, what these drafters will do it when the AutoCAD was introduced, right? So how they will be, so they will be losing the job? So of course not, right? Like they have started learning of AutoCAD, they have started understanding of the AutoCAD, then there is a switch, there is a upskilling. So due to the upskilling, so we could see that we are not just limited to the AutoCAD, now we have come way forward in terms of the digitalization. So one thing we should make sure that digitalization is inevitable, so we had no other options, so that we have to change it ourselves and we have to adapt to the system, and then we have to upskill ourselves, right? So likewise, even now we think about, so we already, AutoCAD also kind of thinking like we already lost the interest in AutoCAD, now we have come way forward with the building information modeling. So where in the building information modeling, like in the yesterday's talk, when somebody was talking about the coordination, so when such kind of tall structures, I think he was discussing about the tall structure and how coordination was built when there is a deviation from the, or there is an eccentric in the structure, right? So that is where building information modeling, it could be giving a collective information of the 3D models. It's not just limiting to the AutoCAD 2Ds. Now we have went way forward, so we have the Revit, we have many of the 3D models. So at least the structural engineering, we are trying to build it up at a stage of bringing the 3D models through the building information modeling, where it should be kind of a database. Obviously the building information modeling is not a software, it is not a tool, so it is a kind of approach we have been adapting in the system, and in the cases of digitalizing the things, and which helping us to coordinate well with as a structural engineer, we could be coordinating well with the architect, so we can coordinate well with the MEP structures, so we can come collectively and then build such a complex structures, even let it be the tall structures or even any by using of the composite materials, right? So this is where we are stand now. So taking to the other level of it, so where we are trying to introduce artificial intelligence in civil engineering, or in particularly structural engineering. So that is to the extent of design, or even to the extent of the fabrications, right? So I think we are the right person to use it. So obviously it's no harm for structural engineers, just to make sure that, so don't think like AI will be harming like the other IT sectors. So we are very safe. So how much very shape? So that I'll be covering in my upcoming presentation. So, but it is advantageous for us. You know, if you have seen the previous presentations, again, if you're taking about the retrofitting of the tower structures, they have placed a lot of sensors. They have collected a huge amount of a data set, right? But whereas if somebody, the data science engineer, so if they wanted to use this AI tool, but where is the data? They don't have the data. So how the data will be generated? So we have ample of opportunity to implement of AI, and this is not going to replace any of our job, right? But this is just will be helping us to upskill. So how to generate the data? So now we have been very familiar, or we are using of all these tools. So this is from the Bentley. So we have been familiar with the StatPro and their subsequent tools such as Stat Advanced Concrete and so on. Similarly, we have ample of tools for digitalization, or in order to make a 3D model, or in order to make our digital structures or fabrications or manufacturing. So we have even a product from the Autodesk. So we have the product even which is very specific for the structural design and fabrications. So even we have products, we have been using that. These are kind of the products like ETABS, SAP, and now to the extent we are going to use this SAPE for analysis and design of the flow systems. So likewise, we have ample of softwares are there, so which are getting connected with the advanced technologies. So now there is a significant gap. So how this kind of the structures, so the data will be connected in order to improve or efficient. Because let's say if you are trying to build some kind of a model in StatPro or the ETAB, so we are making a design which is a repetitive. So when we have the repetitive structures, we can overcome of this repetitive by implementation or by adaptation of the artificial intelligence. So now let me again start from, again, you all know about drafting, we know about AutoCAD. Now just wanted to take it somewhere from the BIM and where the transition been taken for the implementation of AI, right? So just wanted to give this example how the implementation of AI can be done. So we have three kind of the approaches, or what we can relate it to the senses, but obviously I don't want to touch upon the common sense which we have already know and we are very familiar, so being design or fabrications. So another example I would be giving it when you are talking about a driving sense. So if we started like after post of this event in the traffic, so everyone will have your own skills in order to drive. So somebody go fast, somebody go slow. So that is a kind of a transition or the phase in which we all be moving towards the digitalization. And then the same concept is applicable to the design sense, right? So we have seen, so there is significant, even I could not even imagine from the academic side. So where the industry have been doing, there is a significant contribution in terms of the various aspects which we are not in the stage, or we are not in the capability of disseminating this knowledge with our students, right? So as the age, from the generation to the generation, we are lacking of our fundamentals, right? So if this kind of the example, practical example will be more benefiting and bringing the driven forces like this event, academia and industries together so that we can gain the knowledge and then we can disseminate the knowledge with our upcoming generations. So now the only way for us, or wherever we talk about the future is belongs to who will embrace the technology. So we cannot just keep watching like somebody is doing of this technology, we cannot keep watching it. Now we have to everyone embrace the technology, adapt the technology, upskill ourselves and then try to implement it so that we can bring the optimization in our design or fabrications, or we see that we have the data set, how to avoid the repetitions and how to make it more productive, right? So, and at the same time, all these technologies also will go with a big claim. So whatever the claims been made, so always we take a cautions. It is not essentially, it is achieved everything. The simplest way of what we have been doing it is just we are trying to understand the technology rather than just go with their big claims. So because you have seen some of the cars, they have claimed a lot, but it might not be suitable for every conditions. So it might not be suitable for Indian condition, or it might not be suitable for respective conditions. So likewise, our projects are different. So whereas in the design, our projects are different. So or whatever the AI tools or whatever artificial intelligence tools might not be suitable to us. So we should make sure that where we can just improvise in our adaptation or in our design or fabrications, so we can take up such kind of the tools to implement it. So now when we see the shift to the BIM, so even like there are 10 dimensions of the BIM can be made by adapting of various digital tools. So start from 1D, from conceptual designs to you can go up to the renovation. So I don't want to touch upon this much because the most important part of this presentation would be on AI, so I'll try to move on to the AI. So by just adapting this BIM, it can reduce the errors and reworks, because as we have seen the clash detection, that could be the one key kind of a tools where you can understand in the design where you will be optimizing it, right? And you can improve the team collaborations where like in the morning, Vishwanath sir has presented on the slipform work where the crucial of collaboration is important. So in such cases, you can adapt the BIM and enhance the design quality. So enhance the design quality in terms of even the slipform framework or top to bottom approach. So where you could understand the quality of the work is executed. Overall, it will reduce the design team. But now by adapting the BIM for structural engineers, so what you can gain is you can create a multi-material structure modelers. So because if you are trying to do it in a STAAD or ETAB, every time you have to input the data set such as all the material properties. But whereas in the case of BIM, adapting the BIM, so you can have that and then you use an appropriate interface, so then you can convert into the ETAB or STAAD. But now taking it forward, how AI can be interfaced with the ETAB and TAB, I'll be covering in the next slides. And you can use parametric designs to explore the proposed designs, and you can automate the task to save the time and repetitive models. At the same time, you can unify it with the design, because we talk about sustainability, achieving the sustainable goals, achieving the environmental concerns, right? So all you can feed into it, because these stakeholders are not just to the structural engineers. So it collective of architects, structural engineering, MEP, and even all the stakeholders related with the client or related with the end user. So this is one such kind of a project was just done as part of our research. So this is mass house construction being done at Mehboobabaad in Telangana. So how the integration of a BIM and the kind of digital tools called Tekla structures. So I just run through this because you already know the technology, how it would work, and to make you understand so how the BIM would be working in coordination. So this is kind of outcome what we could try with the different construction methods or techniques. So what we tried in this is precast or prefabricated systems, how the prefabricated systems would work when compared to the traditional systems, and how effectively you can make the design optimization, and also it could be helping you out for sharing of the various data set for fabrications, where you will be having a clear-cut fabrications, then you would not face any challenges while executing at the site, right? So now let me come to the AI. So as we all come from the civil engineering background or in particularly structural engineering, so just wanted to give a brief. So this is a AI algorithm is basically the mathematical construct which use some domains, functions and transformations. But obviously what we talk about engineering is not a math, right? But just this will be helping us in certain way by using of this tool. How this tool will be helping us, I'll just trying to cover. So it was introduced way back in 1805 when you look at the mathematical functions of it. So that was introduced by Gauss. But in 1950, then it started mixing the simulations like what we use this heuristics or regressions, regressions in our computation modeling. So, but this became a very popular when we have seen this ChatGPT. So if you all wanted to use AI, just use your mobile, your Google AI Studio. So whatever queries you have it, irrespective of your language barriers, not necessary it should be in English. So you just click on Google AI Studio, and where you can talk in your own language and try to interact. Basically, AI required the efficient prompt engineer or prompter, right? So how will you prompt it? That is how it will be giving you a solutions with the help of ChatGPT, which works on the basis of large language systems or nothing but the models. So this is just a brief history of the AI. It started way back in 1950 and now it became more efficient in 2022. That is where like the ChatGPT was introduced in 2020, right? And if you look at the AI as a whole, then we have the various things, which is basically one of the most thing is machine learning. We'll be using as the creating a AI algorithms. So very simplest way, we have the Python or even MATLAB. So we have used certain programming languages in order to make our designs more efficient. In the similar manner, we can use the AI systems. That is nothing but the machine learning, which works on the basis of Bayesian networks or least square linear regressions, or even various decision tools. So the most commonly what we can use it in order to go for a predictive analysis, or in order to change the analysis, we can go with artificial neural network. So which is generic functions of the approximators. So now AI also come way forward. So there is a significant development in the AI. Now we are somewhere here at a generative AI. So what I was talking about, the app, the Google AI Studio works on the principles of generative AI. So even it can take your text, it can take your voice, or it can even take your images, so that it could predict it and give the results. But it's none of them are very precise, unlike our ETAB stat, right? So this is just will be giving you some predictions, which is just on the basis of some round of values. So now if you look at large scale, so there are different AI language, artificial intelligence algorithms or systems or techniques which works on the supervised and unsupervised learning basis. So if you look at in basis, NLL, so NLP works for decision supports, or machine learning will works for predictive analytics, where we have been extensively using it on our structural engineering in order to predict design, or in order to optimize the designs. And computer visions will be used for expert systems and speech recognitions. So you would have seen the self-drive cars, or even for instance Tesla. So there are many chatbots. This is where I'll be touch upon which of the chatbots will be suitable for structural design. And obviously for additive manufacturing or whatever fabrication we would be talking about, so where we can go with the robotics for automatic scheduling. So if you look at AI is not a new for us. We have been using it for ages. If most of us are already know that foundations of machine learning languages, where we give the input, so that is a known input, and in these functions it will process it, then it will be getting the output. So input is important. How will you get this input? Again, it's a data set. We need the data set, then we can have iterative models. Finally we can optimize it, so to get the very optimistic design from the machine learning. For instance, you use this regression in machine learning, which is commonly used method for regression analysis. Likewise, there are many empirical formulas used for the calculations based upon the some form of the regressions. Now in artificial intelligence, if you look at the further classifications, there are different technologies which can be used as a function of approximations. So the first instant is single layer and double layer, where we talk about a ANN is a double layer. But if you have multi-layer approaches, so with a function of f of x, so you have multiple functions of f of x at various orders, like single order, double order, third order. In such cases, so we can look at whichever is a suitable network systems. We can adapt it, like we have a class. Again, you will be making it more conservative by using a factor of safety for a judgment. The same job, this AI can also do it, where we can avoid it. We'll be having more conservative. Just giving an example of this. So if you have the load, concentrated load of 10 or 10.8, so, but at the end, whatever the reinforcement would be giving it is same. But now, whereas in our design, we do repeated calculations. So if you're trying to develop the AI tools or simple algorithms to do this, so it can use and make a judgment, so that this is in some cases when you wanted to make conceptual designs, you have made it. Instead of going for thorough or detailed analysis or design, so you can quickly have the responses of final design and then do the reverse engineering. So how in detail it is required. That is how the AI could help you out by adapting it, right? So AI is again, so our ETAB or STAT, most of our SAP, it goes with a deterministic approach, where we'll be getting it some kind of a precise values. But whereas in the case of AI, it goes with a probabilistic approach. So it also depends on kind of a data set. So even wherever we have the complexity, let's say if you wanted to make it many of the composite structures or steel structures, so again we would change the challenges with the shape, right? So we have most of the regular shape easier to construct, but when you want to go with the most of irregular or polynomial shapes, so in such cases AI can help us in order to predict or in order to give the results at the earliest. So this AI would be helping you out to find the best materials, shape, size, which are given in a conditions, right? So in order to do that, there are many of the AI agents. So basically we call it as a transformation models, which works on the basis of neural network, and that learns the context from the meaning, or even tracking the relationship between the sequential data. So like the data of the sequence, for example, in this case, when you wanted to predict the kind of a sky color, right? So where you give the input, the sky is, then you will have combinations with this large language systems. There is a huge data set. So it do the kind of a machine learning, it do the kind of analysis, and finally it could give its some kind of the results. So what we are trying to find it out in mean square error or RMSE or R square. So likewise we get some relative data, and based on that we can guess that whichever is the most likely, and that is where the AI could give the answer. So these are some kind of the transformation models. So those transformation models are like we have a GPT, so which was introduced in 2020, and then we have BERT from the Google, and from Meta is used large language models, and Mistral from the France. These are different foundation models which we can use it in order to bring some kind of the aspects in your structural design and fabrications. Again, in order to understand the large language systems, so again you can use that tool of Google AI, just scan these images. It can take you to the complete analysis of it. So this is one kind of FEA analysis which has been done in some of the studies. So in order to get the complete details of this, so just use Google AI tools. There is options to click the picture. You just click this picture, then you could get the complete details of it. That is how the AI will be helping us. Otherwise, again, we have to go with the thorough literature. So we should find out where and what in order to understand the details of this. This is just one such examples in order to go with the AI. And again, if you want to be very specific with the AI applications in bridge design, so we have Sophistic, right? So this is one such kind of the tool which will be already using some kind of the chatbots, or there are plugins with the simplest Python languaging programs which could connect it, as another speaker had mentioned about rhinos and grasshoppers. So how it is used, and then kind of a design optimization being done with the help of AI, right? So here, in order to go with the examples of AI, I just want to touch upon machine learning, as we have unsupervised and supervised machine learning. We have shallow learning and deep learning. So again, I cannot go in detail about explaining of these methods because of the paucity of the time. So I'm just trying to touch upon, and then immediately I'll go with some kind of studies what we have developed in our research. So we attempted, again, one such of the method is predictive method. So where you have the raw data and data processing. So finally we trained the model. We kept remaining, so out of the 100 set of the data, 80% we trained it, and remaining 20% we validated to make sure that the validation of the results. And finally, if it is satisfactory results, then we further went up deploying the model for predictions. So there are a lot of the regression models, and we adapted different regression models to get the outcome of this, right? So yeah, this is just we use for one of the mixed design of the concrete for a self-healing purposes, where in case of a self-healing, it works in two phases. The first phase is we have to optimize. We use some kind of the bacterial agent, and we use a fly ash. So that is the first kind of the optimization. At the second stages of the optimization, whichever the outcome, whatever we get it as the mechanical property, will be serving as an input for self-healing characteristics, right? So we adapted the two such kind of the model. One is artificial neural network, and then we have the ANFIS. So this is how we trained the model. Basically, this is how it would work: input, the hidden layer, output layer, and finally output. And these are different sets of the hidden layers, and their respective inputs were given. And finally, the outcome, what we would get it in terms of the accuracy or rounded off values. So if the rounded off values are having the more errors, our data is not sufficient, then we have to train the data, or we have to train the dependent variables in order to get accurate results from this. So this is where we have the trained data, validated data, and even we done some kind of experimental investigations to test it. So likewise, we have adapted the various regression models. So the random forest or gradient booster techniques, and then finally we compared these results. So based on the outcome of these results, then we modified our input data, and further we trained or we changed our algorithm, and finally we trying to run the algorithm by adapting of the various AI techniques, and finally we could get this accuracy, and based on the accuracy we can predict the data for design analysis. So likewise, even for structural designs, we have various of the chartboards which does not require any of the coding. You just put your input data. So because you already run the simulation in our structural analysis tools such as ETAB or even STAD or SAP, you collect those data, just feed in, because I would have shown it. There in ETAB or STAT, you will get options to get your input data to export or export. So then you take that as the notepad file format, or which is .std format if you are following it as STAT. And in a ChatGPT, you write your prompt, what you want to make necessary changes in your model. You write that prompt and then you copy the complete note, whatever you copied from the STAT. So then it will be helping you to predict the results further, right? So this is how you can use it. For data mining is used for sustainability drivers. And yeah, again, you can take a note where you will be going through this app. Will be helping you to go for sustainability drivers tools to understand, and this will be helping you for structural steel designs. So where you can optimize cost, size, or even in the carbon. So these are the various tools where you can use it: Python, Grasshopper, or Web, or XLX, right? And now we have design bots. So these design bots are used for approach of FEM and bioclimatic analysis. So again, you can use the data set. So where you'll be using a AI app or chatbots to run this. So here the outcome will be get it in this order: weight, cost, and size, carbon. So but at the same time you can change your inputs, whereas column buckling length, then you have axial forces, bending moment. So by changing up these data set, so your output data also would be varying it. So which is already trained, and then you can run the analysis. Similarly for a timber design, so you have another chatbot which is Dicey in your team, or structural design. And yeah, this is chatbot for steel structures. So this is the best way to design the steel structures using the another applications of the AI tool, which does not require of any coding. Just you change your data set and you would be getting the outcome. So again, in a similar manner, we have for designing of the concrete structures, we can use structuralpol.ai. So again, for design of the tall structures, your structure plus, which is again another kind of a AI agent or a chatbot, which we can adapt it for further enhancing of our designs rather than going with a similar structural design tools. And we have Hyper for other design tools. So now, even for fabrications, so I think Tekla is already having an inbuilt AI plugins in order to make your fabrications by exerting the steel connections, design with AI assistant, and automated drawing generation also can be done, and optimize the fabrication process by using of the intelligent automations. And there could be significant time savings in terms of the steel detailing and workflow. So if you look at in detail, anyway, this PPT would be shared. So hope you can refer it, and then you can take the advantages of these chatbots or AI applications in order to make optimize the design. So similarly, as I mentioned earlier, like let's say if you take the ETAB input data, and there is a AI application of Victor AI where you can collect of your data to make your analysis. So that is, as I mentioned about, the availability for data is challenging, and now in order to get the data, like some kind of the opinions, you would be getting it right from the surveying, right? So that is a public domain data, and sometime when we're working in the mega structures, it collaboratively work with architects, structures, MEP, and all the stakeholders together. Finally, we will have some set of analysis. So even including the sustainability, that is a collaborative data. And then you have organizational data, individual data. So one very simple example. So far you have gone through all the presentations with the various presenters. They have presented huge set of the data. You collect that data, and again, if you are using of these tools, ETABs, so you can take the output, use the chatbots, and just plug in over there of your data, and you try to optimize it. Just prompt. The prompt is the biggest role in using of AI. So you make sure your prompt is perfect, then you can optimize it. So likewise, one such case study what we have done it in our, so we went with the digital fabrications, that is called 3D concrete printing. The major challenge is we are going with the no formwork systems. So here we have 3D printing is a layer by layer extrusion, and the kind of analysis what we have attempted here is maintaining the shape under increasing gravitational loads. So by means of the sensors, we try to collect the data. So again, I touch upon the technology which had been mentioned. How can you use the Grasshopper in effective manner, right? So we have the Rhinos where we could make the 3D model, and then we can finally plug in kind of the data of your various parameters. Just I mentioned couple of parameters for your understanding, but you can give what all the input data is required. So voxel size, layer width and layer height, and the assigning material properties. Finally, what we are trying to optimize is print speed and extrusion multiplier. Finally, once we done this analysis, once it made sure, finally we could run this simulation using Abacus, which is a FEA based model. And in the FEA based model, so finally it could give the analysis of buildability assessment and failure analysis. So here I can cut down my time for every time printing and seeing that how much of the buildability it could achieve it. So I can simulate it, optimize my design. Once I optimize my design, so that finally once I get optimized design, it could print up to 14 layer or 30 layers. Then I can finally go for implementation of the printing. So this is kind of a mechanism. I hope you all are aware of it, because most of you heard about 3D printing. So we have pan mixers, pump systems, various data we can collect it from pump systems. Nozzle size also influences on our outcome. And then we have robotic 3D printers. So this print speed, rheology of the materials, and hopper capacities or various parameters, we collect a huge set of the data in order to train our AI model, right? So these are various, just to give you an example, we tried with nozzle diameter, printing speed and so on. So finally whatever we modeled, similarly we tried in Grasshopper. So this was touched upon by the other speakers, where he said about give of various input parameters, and even I can touch upon my Python coding. If it is, I just develop some algorithm, I connect here and run the model, and by running the model, finally I could have the simulations, because here in the simulation where you could give the stability or whatever we can say that deformation under the buildability, right? So likewise we tried with various flexibility in terms of the geometry. So that geometry we were also tried, and we done the analysis. So here you could see that up to which layer we could print well, and then there is a elastic buckling at a 12th layer. So likewise, if you are trying to make a model, then here we have data, generative AI data. You can feed in the text file, and you have the geometrical axis, generated loads, structural components. This is Python programming, which you could be effectively using it in terms of a Sophistic when you are trying to make a design using of this tool, right? So I'll just run through these slides of coding, and then you have various functions. Again, so making it advent of multimodal AI will enhance its power by using Excel, and for a geometrical flexibility you have Grasshoppers, Rhinoceros. Then for analysis we have global model, which is interface well with the Sophistic, and then where we can add our algorithm in Python coding for design analysis. Finally, we could get our outcome in various manners like drawings, PDF or so on. So if you are trying to compare with the FEA and AI, so FEA is a deterministic approach, and where we will be going with the probabilistic approach in AI. This gives exact relationship. This will be giving a rounded relationship. So if you are trying to understand the kind of a relationship, what we would build it in FEA model is this matrix, whereas if you use the ANN, we'll have input and output layer, right? So this is again augmented reality is another kind of a digital tool where we can effectively use for optimization. This is for our IIT Dharwad campus. We used AR for the campus, which is another kind of a digital tools where we can use it to visualize or optimize. These are already existing physical structures. We can convert into the video and try to understand various simulations. Yes, yeah. So let me come to the conclusion. So again, you had a very introduction. So AI can replace what, right? So whether AI can replace the structural engineers? Yes, no, right? Why? The reason is the current AI system inability to perform the precise numerical calculations. Don't be worried. Don't say that no, it may be replaced. It's never going to be replaced us. It's never going to replace the structural engineers. It's never going to be replaced of any numerical modeling. The very reason is, so still cannot be passed the professional structural engineering exam, but whereas it could pass of the exams of medical, law or a business professional exams. But don't be over excited in order to just enhance the use of AI. Still, if you look at the message of this, in the age of AI, there is a paradox. Still students need teachers more or not less, right? The very reason is because students need teachers to get them to the odd things now that are good for them. So ironically, human intervention is required for every system what will be digitalizing it, because that is where you will be giving a rounded value. You have to make it a very precise. So our human intelligence works better than of any kind of the digital tools. So that is a takeaway from this session. With this note, I'll be signing off from my presentation.